Hello, good morning.
Good morning, sir.
Good morning, Nandesh. Good morning, Ishika. How are you doing? You okay?
Yeah.
Good stuff. Okay, let's make a quick start today on time. So I'm going to just quickly share Moodle for a second. I did take some time yesterday to upload a few documents, but want to get everyone's attention on this side that we are going to be looking at for today in terms of study. So what I did was I uploaded the Learning Outcome 2 presentation. Obviously that was there. Learning Outcome 3, which is the full presentation. And then I have the case studies that I uploaded along with some, nice handouts. There is lots of information available on some of these topics, but obviously some of these handouts, the idea was to try and look at the ones which are concise and filtered. So probably each of these are about, 5 to 7 pages or 10 pages maximum. I think if I look at some of these, they are the ones that we are going to be looking at apart from what we studied yesterday, today. So there are some article and journal papers on case studies. They are not related to any particular industry. So what I did was the ones which are short and obviously concise are the ones that I kind of provided, which will give you some idea and background into how these methods in total quality management are essentially used in order to, get the desired output, which is reduce defects, increase quality, meet customer expectations and requirements in terms of products being manufactured. And some of them are research papers, so you might need to glean and read them just as a good read to understand what the concept is. And that would give you, some idea in some of these, for some of these concepts. Now, if you don't read all of them, that is also fine. But basics of what we have read and understood through the slides would also be good enough, because when you look at the tasks for this assignment in particular, when we do the discussions, what you're going to see is it will apply and ask you to apply the application of these rather than talk about in the context of theoretics or theory. So it'll be good to get some understanding and then choose maybe an organization that you are comfortable with, that you can research. A lot of people choose Toyota in general or General Electric in general, or organizations which are in the European context, Indian context, Pakistani context, or Middle Eastern context. Mostly they pick up hotels because obviously it is easy to get data, and there is, the websites are quite well equipped in terms of providing that data, and that should allow you to use one of the organizations primarily. If you choose to do something different than what has been given in the case history or the scenario of the assignment briefs. So it'll be good to look at having one or two organizations shortlisted so that you are starting to research that data, and that would be then useful to discuss and do some of the tasks in the assignment brief. Now, very briefly taking you back to unit spec. So we covered yesterday, the role of total quality management in, operations management, and we looked at lots of different techniques which have been, invented and now are very well established and accepted globally or worldwide, and they are basically used as, proven techniques to be able to look at monitoring quality, looking at meeting quality standards, and also looking at using these standards for quality assurance, so that the products or anything that is being manufactured is essentially meeting the requirements of what the customer demands are in particular. So here is where we are looking at understanding the concepts, and then in the second part of what we are going to discuss today, we are looking at essentially going into understanding how do we apply some of these techniques that we studied yesterday. So Joseph Juran and Edward Demings are basically credited, in terms of creating some of the, let's say, documenting and obviously creating some of these techniques which we use today, apart from Toyota Motors and some of the manufacturing companies in Japan, which led to the creation of Kaizen or continuous improvement, CQI, continuous quality improvement as a process. So today we are looking at the CQI part being put into practice. So what we initially learned in the presentation, if I now switch over, And we started off yesterday with regards to, the presentation, and we started with the first slide, which was talking about the concept of continuous quality improvement. We have to now put this into practice. That means using some of the techniques that we have learned yesterday, what we're going to then do is basically, look at putting these into practice by studying by use of an example. So we looked at Deming's PDCA cycle, Six Sigma approach, resource-based view, or the other view that we also talked about was VRIN, V-R-I-N. And this is because if resources are finite, and I gave an example of the Coca-Cola bottling plant, and if they look at, the theory of constraints, if they are seeing increase in customer demand, they are looking at increasing manufacturing facility, they are looking at competition, and they are looking at also, in general, how their operations would be affected. So theory of constraints looks at, okay, they might be constrained in terms of increasing capacity within the bottling, side of the factory. There could be constraints in terms of customer demand. It could be competition. And one of these constraints could affect, the expansion or the increase in capacity, which they are looking at doing. So looking at some of these frameworks that we discussed yesterday, including Kaizen, lean management and lean thinking, theory of constraints, business process reengineering, business process management, BPM, and then business process management softwares, we are going to now look at putting some of these into practice of how companies and organizations actually use these concepts to put them into practice for improving quality and looking at, meeting, say, for example, customer requirements. Now, one of the things that we are going to start off with today would be primarily looking at, understanding what is product quality and what is process, what process is required to look at improvements of product quality. And that is where we will be looking at focusing on things like process architecture, quality circles, and statistical, process controls. We briefly looked at the role of technology in terms of business process management, software, decision-making, decision support systems, knowledge-based, systems, and then softwares which are employed by the organization in general to be able to, connect various departments so that the flow of communication, sharing of data, and, effectiveness in terms of managing inventory, say, for example, raw material supplies and other type of things can happen. And that creates less waste, and it is connected to just-in-time, and the just-in-time system essentially also looks at working very closely with lean thinking, wherein the idea is to reduce waste being produced as an output from an activity being done. Now, what we're going to look at is understand, in general today, before we go into continuous, quality improvement, what we need to understand is what is product quality. So how do we define product quality? What is meant by product quality? So when we look at product quality, what we are looking at is essentially how the product meets the requirements of the customer. How does it serve the needs and demands of the customer? So, for example, I want to buy, for example, an iPhone. Now, why do you think there is a requirement of the iPhone? Why does the customer need a phone which is a normal phone like a touchpad, phone, keypad-based phone, and they are looking at migrating to a touchpad-based phone? So so if you think on and put on your creative hat, what you're looking at essentially would be that if we, for a moment, look at analyzing why do you think there is a need? It could be that the customer is now looking at performing multiple functions from the phone, sending emails, taking pictures, looking at app-based interactions with, certain applications. And that is where the keypad-based phone is no longer suitable. So if we understand that that is the need the customer has, and then we design the product, then obviously it meets the requirements of the customer. And while the customer's requirements are met and the subset of the requirements which they need in terms of preferences are met, that allows the company to then look at finalizing or working through a product which is then serving the customer's need. So when we look at product quality in the context of business and manufacturing, what we are referring to is the product which meets and exceeds certain standards and requirements set by the customer. So in this case, the iPhone, for example, or a touchpad-based phone, basically not just meets but exceeds the requirement. It has a camera, let's say high resolution camera, both front and back facing camera. It has the ability to run multiple applications. It allows you to send emails, look at taking photographs, doing voice recording, talking on the phone. So it is meeting more or less not just the requirements customers have today. It is now enabled with NFC, near field communication, so allows you to make payments. So these are things which companies are adding to increase the product quality or better the product quality of the product, like a smartphone, in this case, an iPhone. So when we look at encompassing various aspects of product durability, reliability, performance, safety, and overall excellence, meeting the criteria of the requirements of customer, then is what we will say is this is product quality. Now, when we talk about process quality, if we have to use the term process quality is related to engineering, which means the field wherein the product is being manufactured. So process quality will be a critical aspect of quality management because that focuses on the effectiveness and efficiency of various processes that are required to create that product. So it is a bigger part than product quality because products are manufactured, but they are manufactured using process. So the process quality is focused on the efficiency and effectiveness and agility of how the operational side of things would work within the factory. Assuming, going back to an example that obviously there are, say, X number of cars being produced on the shop floor or on an 8-hour shift, and the shift has a breakdown quite often, every 2 or 3 hours, or there are some shortages of inventory, or there's a breakdown which happens because some part of the assembly line breaks down, or time required is not being calculated properly, so it is leading to jobs piling up and the factory line not moving in line with what they would have anticipated. So here the operations manager, or the person who's responsible for that shift, the production manager, line manager, operations manager, factory manager, site manager, whichever way you call it, depending on the size and scale of operation, what you are going to see is that person would be responsible for improving process side of things. That means they will need to relook at how the process has been defined, what is the time allocated for each activity to be performed by either humans or robotics, how fast the line is moving, how quickly the delivery of goods are happening to the line in terms of things which are to be integrated and assembled onto the factory line. And if there are gap areas in that, they will be streamlined through the process of process quality. So here it involves monitoring the systems, analysis, improvement of these processes to enhance the performance and align it with the requirements which are there for the say the factory floor, so that everything is running smoothly. This is something that you will generally see, when I give you an example of process quality, you are generally going to see this in the field of manufacturing. You're going to see it in healthcare. You're going to see it in education, software development, because here the processes would need to be streamlined to produce an output or a product which actually meets the customer requirement. So in software development, if I look at an example, if you are charged with leading a team, or you're charged with developing an application for a say iOS or Android Play Store, Google Play Store, and that application development requires certain processes, that means flows of how things would move, to be first designed. And then using those flows, programmers will go about coding, testers will go about testing the code. You're going to then look at alpha testing, then look at beta release. And at some stage, if everything is working and there are no bugs or errors coming into that software, you're going to list that on the apply to list that on the iPhone, iOS store or the Google Play Store. So here, software development would follow a certain process quality that is focused on, ensuring that the software code is in consistency, or is the code being done by the programmer are in consistent guidelines with meeting the customer requirement. The output of that software should lead to what the customer is expecting. And then The efficiency of coding practices would be tested through the process. Testing procedures itself will be tested. And as a result, the whole project, which is being managed by, say, for example, a project manager, would go through the whole compliance of process quality improvement. And that is where they will ensure that the process quality side of things provides the output of the product in a way which meets the customer requirement. Now, at any given stage, you would always be looking at, between the two, you'll always be looking at using plan, do, check, act, PDCA cycle. And that is an important part of process/product quality improvement programs, because you do the things in a particular way, then you check, you plan for it first. Once the plan has been approved, then you start doing them, implementing them. Then at some stage, you check the output. And if the output is not meeting the expectation, you make course correction procedures or do some more changes in that, and then act on it again to see and take feedback. And this process of PDCA, which is plan, do, check, and act cycle, is a continuous cycle which is employed during the workings of process quality, and then in the case of product quality. So process quality, how? Because the product is being manufactured and the output is not coming as expected. So in this case, what will happen is that they will go back into the drawing board, start looking at the process again, look at the gap areas, make some changes, then implement it. Then again, essentially looking at ensuring that, the product is conforming to the customer requirements. On the product side, when the product goes to market, companies do a lot of feedback and surveys, check the quality of the product requirements, does it meet? And then if this is, say, for example, if there are areas which are gap areas, then the feedback process, the research surveys that they do are brought in, fed back into the system. And then again, modifications or variations on the products are essentially done. So here, when we talk about, product quality and process quality in relation to compliance of requirements, specifications, and customer expectations, we are comparing this mostly to the process efficiency, because that is being used essentially to create the product. Or, you're not looking at making one product, you're looking at making it in hundreds, thousands, and even millions. So if bottling of Coca-Cola is happening, that's not happening on a one-off basis. It is happening on a daily basis in hundreds of cases, being produced from the factory. So obviously the process has to work right. If the process is not right, the line breaks down, or there are problems with the production line, and in those cases it leads to delays and obviously loss of business and loss of revenue. Now, a table that I've drawn just as a comparison across a couple of factors, things like when we look at process quality and product quality, we are looking at compliance requirements, we are looking at specifications, customer expectation, and process efficiency. And across these four parameters, you can differentiate easily what is process quality and what is product quality. And then how improvements can essentially be done by looking at these two processes or two different side of quality processes by operations managers. Now, there will be people in quality assurance, and there'll be people essentially in operations management who would probably be looking at these processes differently. And this table gives you a bit of an idea in terms of how the comparisons can be done. Now, product quality might be looking at conforming to legislation which has been set. So, for example, cars, sticking to cars, if you look at cars being manufactured nowadays in Europe, the fuel compliance, regulatory authority essentially looks at all cars meeting the carbon emission guidelines of Euro 6. So essentially, catalytic converters are a part of all cars being manufactured, and they need to conform to standards, which is, I think, Euro 6 emissions. If I've not looked at it, but if I remember it correctly, it is Euro 6. It might be different in different countries, but this is where it is complying with the government guidance of, carbon emissions. If you look at specification, the designing of the exhausts of the cars will need to ensure that the quality in terms of the catalytic converter and some of the other components which go into managing and the emissions of the car, and then changing into carbon monoxide or less of carbon monoxide and more of carbon dioxide would be required. And in this case, the product designing would need to be looked at. Customer's expectation would be looking at getting hold of a product which runs for a number of years without any problems, no need of replacements or things like that. And that is what would be, prioritization from a customer standpoint of view. And process efficiency would be that although this particular side of the product is not looking at overall, product efficiency or in terms of customer requirements, but is one of the key requirements now when we look at, customers' expectation. In some cases, if you look at modifying some part of it, would be like customers' expectation is to have a semi-hybrid or a hybrid model wherein it runs on fuel and it also runs on batteries. And in places where you go, wherein there's a, let's say, a surcharge or a tax applied because of green roads, in those cases, you can switch to battery operations. And in other places, when you are running the car, you are switching back to the petrol operations. And that also allows the batteries to be charged. So when you look at process efficiency, that might be one of the considerations in relation to product quality, which the customers would look at. And on the flip side, if you look at process quality, you're looking at enabling processes that will, in the organization, when manufacturing, when creation of new products are being done by product managers, they clearly understand the requirements on compliance side and then design the processes in such a way that the compliances are met. They are looking at optimizing processes to achieve desired specification. That means they should be very clearly having a pulse on the requirements of what customers are needing, where the market is moving, and what is the demand in the market. And they should then design, when I say they, I mean product managers, quality managers, production flow managers should be looking at designing processes which are optimized primarily to take into account these specifications or requirements from the customer. And then the processes that they're designing need to be efficient. Today, for example, if you have to order a car, like a premium car, say, for example, if you look at Bugatti Chiron, now there are so many cars which are manufactured. You look at ordering a Ferrari, you look at ordering a Lamborghini. Some of these very expensive, sports cars may require a lead time from the date you order to the time you get the delivery. So here, the process side of things have to be defined in such a way that when a customer order is received and some payment from, say, for example, you're buying a Rolls-Royce and Phantom, and that is received as an order from a customer, and it is a customized order wherein things have been asked to be changed or adapted to their personal preferences and style, then in those cases, the factory should be equipped to be able to produce that model in a certain required amount of time. It can't be that, okay, because you asked for snake leather or crocodile leather as an upholstery, the car manufacturing will take, standard time for a Rolls-Royce Phantom is 6 months, you will get it in 2 years. Who would wait for 2 years? So in those cases, the operations managers in various roles would be required to efficiently derive these processes, which are basically looking at helping to meet the demands of the customer. That means the order which the sales team or the BD team has been able to get. And that is where you will be looking at process quality. That means what that would mean is they would have partners and suppliers or supply chain in a place, which is meaning if they get a demand for these products and they have been given these options at the configuration site, when in the dealership, the customer is able to choose, then they should have suppliers, partners, and a supply chain in place to be able to secure and procure that product in a small, efficient, and in a short duration of time, thereby looking at completing the order or the requirements from the customer. So there would be differences in process and product quality, and they would have different workings as far as the operation side of things are concerned. Is this bit clear? Any questions on this particular topic?
No.
Okay. Now, if we look at, say, for example, the contributions which both these side of things make, product quality and process quality. So what I've done is elaborated this table into details, like I've given you an example. And what does the role of compliance mean for the factory? What does the role of compliance means for customer? What does the role of process quality in terms of operational efficiency and the role in terms of compliance? So I've elaborated these just to make you understand, the aspects of it. Now, the second part that we want to look at is in continuous quality improvement, CQI, is to look at diagnosing quality problems and reducing errors using SPC, statistical process control. Now, why is it that you would need to look at, diagnosing problems? And how would it be possible for you to look at diagnosing these problems? Now, if I produce one product or one batch of products, what you're going to essentially see is that that batch might not have any problems in it or would be, say, defect-free. But when you start producing in volumes, I mean, it's thousands and millions, and you're doing this, and the factory is doing this on a day in, day out basis, 365 days a year. At some stages, there would be slippages or mishaps which will happen, which will lead to defects in the quality of the product being produced. Now, in order for us to look at diagnosing why these defects are happening, and also to understand that, how do we diagnose the problems that can be faced essentially, because of these defective products being shipped to the market. What will happen is many organizations will follow what is called an inspection process or an inspection regime. And when I say inspection process or an inspection regime, that would mean that they would be looking at testing some of these products for quality related issues. Now, if you look at, again, sticking to the example of car manufacturing, you look at cars which are like Ferrari and Lamborghini, and customers are paying hundreds and even millions in terms of pounds for these cars. Some of them cost in excess of 300,000 pounds. Now, if customers are looking at buying these cars because they are standards or benchmarks of quality, they are premium, they are paying that premium in terms of buying that car, and they expect that the car which they are going to get from the factory is going to be meeting the requirements or exceeding the requirements in terms of at least having no defects, no problems, no faults. And that is where what the factories would be looking at doing is, you look at the, when Ferrari claims that it's 0 to 60 in 4 seconds or 3 seconds, that could be tested, by the customer. And in some cases, if it is not meeting the conformance and the guideline, the customer would be well within its rights to go back and say, no, this benchmark you mentioned is wrong. So what will happen is, test drivers, when some of these cars are produced, they would also test one of the cars, by randomly picking up from the batch it has been produced, and then tested on the track to see speed, agility, performance, stability, and in general the wear and tear and the endurance of the car. And that is where, if you look at in Germany, Nuremberg, the test track has been created. Ferrari or some of these large factories, of Lamborghini and other factories like BMW, they always have a test track within their factory premises. And it is not a small track, it is like a 3-4 mile track, which essentially is used to test these vehicles. Now, why is it being done? Is because they are looking at diagnosing quality related problems, defects, or errors or problems which could occur within the product when large batches of these cars are being produced. And they are going to randomly pick up one and then put it to test to see if there are any defects, problems, issues with what has been produced by the factory. Now, when you do this in volumes, and when the production of Ferraris, for example, if my memory serves me right, they manufacture somewhere about 5,000 to 5,500, 5,600 cars a year. Now, if they are to look at defects in the car, one, there should not be any, because that is why people buy such a high quality product. But if they are to detect a defect, what they would need is a bit of a, let's say a volume of products across which they try to, check for these defects. So 5,600, assuming how many Ferraris are produced, assuming if there are, 5,000, being produced in a year, then what we are looking at is so approximately the correct number is 8,400 Ferraris are produced a year. So if we look at, defects being looked at, diagnosing of defects or issues or errors, they will need to study all these produced cars across a year and for a number of years. And that would allow them to then get a number which would then predict what is called, say, for example, defects that they are going to get in the number of Ferraris being produced. So when we talk about diagnosing quality problems and reducing errors using numbers, then we are going to use the process called SPC, which is statistical process control. Now, this process becomes valuable because it will be helping the engineers and in this case, the quality managers to diagnose problems related to the cars which are being manufactured in a particular year, thereby allowing them to reduce and maybe look at making changes to the process and product quality control so that these errors can be reduced or done away with in the subsequent years of manufacturing. So most of these companies would study the product quality, the batch, test out the cars in a particular batch which is being produced, and this will be based on looking at doing data crunching or data which is driven from collection by testing some of these cars to check for defects and issues. Now, another example that I would give is when you look at Tesla, for example, Tesla, collects, when you connect Tesla into a charging point, which are Tesla charging points, it downloads all the test driving, or not test driving, but all the driving data from the car into the computers or central computers of Tesla, motor company. Now, the reason why they are looking at collecting this data is because electric cars are still pretty new. And what Tesla is also trying to do is look at using this data to look at coming out with driverless technology cars. So in this case, it needs tons and tons of data, which is like volumes and volumes of, or megabytes and megabytes of data, which it can use from its cars, in its performance of its cars, and then use that data to basically make decisions. By crunching that data, they will be looking at making data-driven decision making process, which would allow them to create what are called control charts, and that would be essentially the reason of collecting data. These control charts would essentially allow the company to monitor, control the process, and then over a point in time, use the data to streamline some of these processes when they reach what are called statistical limits. Now, if I say, hypothetically speaking, that, when the cars are tested and they say 0 to 60 or 0 to 100 miles per hour in so many seconds, this is a benchmark now established primarily for sports cars to be able to say, okay, this is the fastest sports car on the planet, or Bugatti Chiron is the fastest car on the planet. Or if you look at, Porsche Targa Forest is the fastest car on the planet, or Mercedes AMG 630, is the fastest. Now, how do these benchmarks come across? They have established a benchmark that 0 to 60 or 0 to 100 should be in so many seconds. The lowest number of seconds that the car takes would then establish that car in that category as the fastest sports car. Now, there are limits to that. You can't have 0 to 60 in less than 2.3 seconds. If it is also made possible and they claim this statistics, then it might be under test conditions wherein the car is not actually a car, but the engine itself is being tested to check that capacity within the plant or within the production facility. But benchmarks, when they say road-friendly benchmarks, that means the cars are road tested, and those benchmarks are then published for the purposes of advertising, promotion, and obviously quoting. Then in those cases, you're looking at these benchmarks being established over a point in time. Now, when I use the word statistical limits, what I mean by that is that 0 to 60 can't be in 1 second. What they do in terms of innovation, or 2 seconds or 3 seconds, 0 to 60 for most cars remains in the limit of between 3 to 4 or 4 to 5 seconds. Now, there are statistical limits to it. They cannot look at improving quality, or in this case, the process benchmark cannot be decreased, because there are limits to what the this combustion engine can actually help achieve. And that could be whether you add more pistons to it, whether it's a V6, V8, V12 engine to it, or it has got turbochargers in it, or whatever you say, it is not going to beat that benchmark of going below a certain time in terms of 0 to 60. And that is what we will say would be a statistical limit or limitation because of the limitation of the internal combustion engine. And that is where the speed of the cars could be restricted. Now, when you talk about Tesla, there is a ludicrous mode in Tesla. Ludicrous mode basically allows you to customize the working of the car to suit your requirements. And in ludicrous mode, Tesla accelerates theoretically from 0 to 60 in 2.3 seconds, and it beats all the cars on a quarter-mile drag race. That means you are basically running the car and testing it in a quarter of a mile. And if Porsches, Mercedes, Chevron, any of these sports cars that you look at from any manufacturers, and if they are to look at a quarter-mile drag race, what you're going to see is that Tesla is going to win outright for 0 to 60 at 2.3 seconds because it has no motors in it, apart from the motors directly driving, the speed in the speed of the car or rolling movement of the car. There is no engine parts, there are no gear changes, and all these things limited to a efficiency of 2.3 seconds for 0 to 60. And that would be a twin motor based Tesla S series or a T series, and that is what essentially would reach that benchmark. Now, anything beyond, if they improve, make improvements, whatever it is, that would mean that they would need to spend lots and lots of money on research and development and improvement of quality processes to bring it down from 2.3 seconds even to 2.2 seconds or 2 seconds. And that might not be, commercially viable for the company. And that is where we say we hit the statistical limits. So the process here begins with collection of data. The collection of data is done over a period of time. There are a lot of collection of data which is done in terms of gathering those data points over time, and that data is then analyzed using statistical tools to create what are called control charts. And these control charts essentially allow the processes to be monitored and checked in order to avoid any variations that can happen. And these variations essentially lead to what are called defects or faults. And when this is done using the technique of crunching data and data-driven decision-making to design control charts, which are used as benchmarks, it would be fair on me to say that they are utilizing what is called the SPC or statistical process control to drive quality improvement, within the organization or within a manufacturing of that particular product. Is that okay? Is that quite clear as an example? Is that okay?
Yes, sir.
Okay, now let's look at, say, for example, some of the other aspects in this. So SPC and, diagnosing quality problems and reducing errors would primarily be looking at creating what are called control charts. So if I give you an example of a control chart, just to look at a visual example, let me see if I can bring out a control chart example. There would be, processes or flows essentially that we get to see, in quality control, which would be, something synonymous with for example, the office of a quality manager, or, essentially somebody who is responsible for, streamlining processes within the organization. So let's look at an example of a quality chart, which I would show in the form of, say, a bar chart, and that would be, a quality chart, if I have to put it this way. So this would essentially be a decision-making chart, which is based each part of this, phase where each part of the flow where the decisions are made. That means yes or no, or, in some cases, looking at reducing defects and errors, they are going to be defined. And obviously some part of this will be then tested through certain established controls which have been done, and they would be termed as what are called, essentially control charts. So in this case, control charts tend to be, if I look at a software industry, you would generally see the control chart clearly depicting how the data is essentially, say, for example, retrieved, and how the, data is essentially, put to use in certain activities, and then response taken. And that would be, in this case, this is an example of, learning machine language chart, wherein the RAG engine is actually trying to retrieve information to give information as per the user request. So these are data charts which basically, or control charts essentially, which are established to visually depict the, let's say, the flow of information or flow of how the process is going to run, and they would then be used and using a lot of data which is collected over a period of time, they would then be drawn up and they would be used as benchmarks to basically reduce defects or diagnose any sort of errors that might occur essentially in production or production line for a particular product. So these tend to be done through what is called statistical process control, SPC, and that is where this is quite useful and important, because data helps you to understand variability. Data will help predict certain insights, because if there are things showing a bit of variance, and that variance would be highlighted over a period of time, that would allow quality managers to be able to detect this variance and then look at why these faults are happening. Some of these are then also used to make adjustments and also look at looking at developing what is called root cause analysis, and that would be to primarily find out what would be the underlying reasons of why this particular process or defect is happening. And in order to not base it on say assumption or any sort of presumption, here data would be used to back this up to say, these are the number of vehicles, or this patch is what has been analyzed. These are the number of vehicles which are having a problem. And sometimes you see, to quote an example here, sometimes you see that when vehicles have been shipped, they've been manufactured, customers are driving it, they've been sold, there will be a recall which will be done by the factory, because SPC has been used by collecting data and then crunching of that data to see whether this will lead to a defect or a fault in the future functioning of the car. And you see recalls of cars being done by Tesla, Toyota Motors, Nissan, Ford, General Motors, every manufacturer across the globe at some point in time, because what they do is once they start getting the data, they crunch it and then look at decision making on the basis of that and diagnose if there are going to be faults which will occur. And sometimes you would see companies would offer free replacements of those parts, including labor, because these are factory faults which have been discovered, and they have a potential to be fatal if it is allowed to run in that condition. And that is because of data being collected, data-driven decision being made, and then the recall of these cars sometimes is done in even thousands by companies as far as the defects are concerned, or defects which may arise which do not get detected at the time of manufacturing and shipping or selling the car, but they are visible when the usage data is collected, and that shows that these defects are going to be occurring in the car. So this process of continuous quality improvement, CQI, is done using both parts: product quality improvements and process quality improvements. Product quality improvements might be done using studying customer requirements and the product meeting the customer requirements. But the process quality side of things are detected and improvements are made using statistical data, which primarily either allow data-driven decision making, or in some cases allow the anomalies to be picked up after the product has gone into usage, and the usage data would then provide insights into why these defects or these variations are coming, which are leading to defects or issues or problems arriving in the product. Is that okay? Is that clear enough?
Yes, sir.
Okay. Now let's look at reasons of variation in product quality. Now you can always have, like it's called the moving goalpost. Sometimes, in your life, when you have your personal goals, you move from becoming something or doing something to something else. Now, when we look at, reasons of why variations of product quality, processes might change within organizations, there could be a number of reasons why this could happen. For example, if we look at the TVs and we go back to the 70s, we would look at it from today's point of view and with a hindsight that, there was poor product design at that point in time, because we produced what are called cathode ray based TVs. Now, this in effect a sentence or as a statement is false is because at that point in time the technology was not developed, and some of the LCD, OLED, or these kind of plasma parts, or technology itself was not there, which allowed these products to be produced. We could also say sometimes that this product, sometimes we do see, sticking to the car manufacturing examples, sometimes you see certain models of car manufacturing companies, if they introduce a certain model, the model does not create traction with customers' requirement. Although the company has taken and made the best possible efforts to look at, say, for example, studying customer requirements, ensuring that their requirements creates benefit, then studying those benefits and then bringing them back into product development side, and then producing a product which will hopefully be bought by customers. But sometimes what we do see is that the products fail to create traction. So, for example, if we look at certain car models of Peugeot, or if you look at certain car models of Citroën, they have failed to create traction, with some of the models that they produced, like Peugeot 406. That model was a lot of hype around it, that this is this model, this is that model, and it has all these advanced features, but the model failed to create traction with the customers in terms of purchase. Now, this could be because they have taken into account some of the features which customers wanted, but the output of that product has come out slightly different, and that would be attributed to poor product process design. That means the requirements were not, correctly conformed to a product design and development, and as a result, the processes were flawed, and that is where what we get to see is the product failing to meet the requirements or creating traction with the customers in the market. You could also have variation in product quality processes because the operations which have been set up are unfit. For example, if a company decides to, say, go into operations in the Middle East or in any particular country, and they fail to understand the cultural sensitivities of the requirements from a customer's perspective. So if I look at India, for example, if McDonald's goes in and they start producing or serving beef burgers, now that might be, an unfit operation design, because in the Indian context, beef or cow is considered sacred. So people would not eat because of cultural requirements. But that product might be a big hit in other countries like Middle East or other countries wherein say, for example, beef is consumed. So companies sometimes have to look at conforming to looking at variations in product and process quality because of reasons of product design, poor product design, unfit operations. It could be, for example, untrained manpower in some cases, or if there are variabilities which are coming, or variance in terms of differentiation coming in terms of procurement of raw material from their vendors. So when you buy a McDonald's burger, or when you buy a Subway, or when you buy a KFC, and you go in and have a meal with the family, it tastes the same whether you have it in X country, Y country, Z country. The process has been designed in terms of procuring the raw material from local vendors in such a way that the taste of the burger or the whatever you're eating, is exactly the same across the board in so many countries. And this is due to basically the process design. Now, if there is a variation which happens, for example, the potato chips that you buy in McDonald's are tasting different in India from Ireland, from UK, or from France, then there is a variation in terms of incoming raw material which is coming from the vendor. That means proper checks are not being made, adequate supervision is not being done, and that is leading to farmers producing or selling, or producing that raw material and selling it to McDonald's, which is not now leading to a change or variation in the taste of products being produced in different countries. And that is where you would generally see, variation in product quality versus product process quality, because they fail to recognize that this product is not meeting the conformance standards which has been given by the company to the farmers to be able to produce potatoes, which would then produce the potato chips. And the process by which, once the batch has been produced and tested and inspections have been done to see whether it meets the requirement, is not being done properly, and that is why these variations typically would occur. So here, the primary focus of quality managers, quality assurers would be to understand what is the root cause of these variations. And these root cause of variations will need to be put into what is called a corrective action plan, CAP. And these corrective action plans would then be run within the process or will lead to changes within the process and product quality side of things in accordance with the frameworks of TQM, Total Quality Management, and Continuous Quality Improvement. And these are things which are used primarily to ensure that there is no variation in quality of products, which can happen when companies are having multinational companies are on. When I say companies which have operations globally, multinational companies would have in selling their products and services to consumers. Now, how would these variations in product and process quality be tested? And what kind of variations can essentially happen? So let's look at one, why these happen and what could be these in product quality and process quality, and then look at some of the tools and techniques which are used under TQM and CQI to detect these variations in product quality. Now, reasons of product quality variations could be material inconsistencies, which is in terms of raw material being secured, human error. It could be equipment variation. For example, manufacturing facility or plants in certain locations have tied on and taken certain machinery, and that machinery is producing the output slightly differently to what it is expected to be done. You could have design flaws, which could be, how the instructions are fed into the machine, or how the control charts have been created to basically let these machines run, and then the input is being put in a certain way wherein it is leading to design flaws which are coming across, or basically inconsistent quality which is coming across the products being manufactured. And in some cases, it could be environmental factors, for example, temperature, humidity, lightning, and they could also affect product quality. Now, when we look at process side of things or process quality side of things, what we are going to see in this case is there are operational inefficiencies. That could mean, for example, if a plant is manufacturing or is put up in a tropical climate, and if it is producing, say, temperature controlled goods, and machinery is operating 24/7 in 3 shifts, for example, then the machinery would need to be in a controlled air-cooled environment. And if temperature is high, humidity is high, that could mean that the machines could have a lot bigger wear and tear, and as a result, breakdown. So if they are not able to adapt to these changes, wherein, for example, if you look at software companies with large data warehouses, like you look at Facebook, Google, they run complex operations which involves thousands and thousands of servers, and they are in data warehouses. Now, data warehouses, where these are installed, they are all temperature controlled, because when you have, say, 5,000 servers or 10,000 servers operating continuously, they need a controlled environment in terms of temperature, humidity, which would allow these machines to run efficiently. If there is no proper air conditioning, then in those cases, it will lead to operational inefficiencies, because the machines would slow down, they would be affected by environmental conditions, and in some cases breakdown, which would mean more time lost or equipment having to be replaced. Then you look at resource constraints, you look at management policies, you look at sometimes technology issues and external factors. These could all affect process quality. These factors are different from factors that affect product quality. So in some cases, for example, if Marks and Spencer, for example, how do I give an example of difference in process quality versus product quality? Let's look at Marks and Spencer manufacturing shirts. And this shirt, they procure cotton from Egypt, the Egyptian cotton, as we say. And this cotton is produced, in a particular type of climate within Egypt, Algeria, and Morocco. When it is produced, it is shipped to, say, Bangladesh or Vietnam, where these shirts are going to be manufactured. Now, where would the variation come in product? That means if the farmers in these countries do not produce the cotton with the required specification, at some stage when the spinning of yarn is happening and the final product is being produced, you would find a variation in the quality of the product. That means the cotton might be a bit coarse, might be a bit fine, or might be a bit, different. And that could be easily detected by the human hand by touching the output of the, finished product, essentially. That would lead to product quality variation, which means the variation in terms of material which has been produced. So, for example, if Algeria has low rain this year, then the cotton produced in the cotton bulbs would be less, and that would require more of that to be used to produce the shirt. But if it has been raining well and it's been well, climate has been good in other countries, then the output might be slightly better. The cotton produced by the cotton bud or the cotton seed might come out much better, and that would lead to quality variations in the product. Is that okay? Now, process-wise, if these shirts are manufactured in different plants, in say different locations within Bangladesh and Vietnam, and there are two different factories where manufacturing it, but if they take, for example, manufacturing of these shirts in say batches, and these batches would then have variations. How would they have variations? The variations could be in terms of how, for example, the machinery and plant has been set up in these locations. For example, if the sewing of the yarn is the settings of the yarn in terms of how it is sewn is changed from 0.002 to 0.0021, you would generally see how the the process, that would mean there is an alteration in the process of spinning the yarn, and that would mean that at some stage there will be a difference in the output of the product which will be produced by those machinery or equipment within that location. And that would lead to a process inefficiency because the parameters being fed into the machinery to produce the yarn are not the same across the two locations. Now, sometimes there could be adjustments being done primarily because of external factors like humidity, temperature, and you might need to make these, but then that will be set within the acceptable limits of what variation can happen in the product, because they have been manufactured in two different facilities, and two different facilities might not be able to produce exactly the 100% exactly the same type of product. So in those cases, limits on variations are put that 99.9% or 99.1% of the product would be within the same category and guidelines as defined by the product manager. And in those cases, you would look at an example of process quality variation versus product quality variation. Is that okay? Is that clear? Is that clear now?
Yes.
Questions? Any questions on this?
Yes, sir.
Now, let's look at some of the tools and techniques which are used to detect this process and product quality variation when we talk about TQM. The role of product, quality managers, quality assurers, how would they detect this variation? Now, there are certain tools and techniques which have been accepted globally, and they have come across as models that are widely accepted and now used within many different sectors and industries. One such tool and technique that we will look at is Taguchi loss function. Now, what is Taguchi loss function? This is a concept which was developed by a Japanese businessman and statistician called Jinichi Takuji, and that is why it has been named after him. Now, he used quality management to quantify the cost of poor quality or deviations which can happen because of the product being produced let's say, not meeting quality standards set as far as the paper is concerned. Now, when car engineers, going back to that example, when car engineers and product managers sit down and produce a variation or a variant of a car, and they define this will have the V6 engine, this much will be the CC, this is the fuel consumption, blah, 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 and they make a detailed product sheet. Now, when the car goes into production, if it deviates from those qualitative factors which have been defined in the product sheet, then what you're going to see is there is a cost that will be required to conform to the poor quality or deviations which have happened from that product sheet initially designed by the product manager. And this concept, which basically is significant primarily in manufacturing, because you're making goods in thousands, volumes, or millions and millions across the month, across the year, year after year, leads to cost that we can calculate, and this cost actually conforms to cost of poor quality or deviations which have happened from the ideal product specification which was defined at the time of putting the product into manufacturing. And this to be detected as a let's say as a if I put it this way, that this, if it has to be detected here, it has to be basically looking at identifying the let's say the I'll put it this way, the product quality. And this would then be because if this, for example, deviation is happening in the product, and if there is a cost now coming to meet that quality or keep it up and running from a customer standpoint of view, this cost would be calculated using the Taguchi loss function. So why he calculated this, why, for example, why he gave us this mathematical formula is because this allows the company to calculate the losses which can occur because the product is being produced has not conformed to the quality standards which have been set in the product specification at the time of manufacturing. So in other words, what I would say is, if as product or process move away from any sort of desired specifications, there is a cost which is associated with it because it creates defects in quality as the products are shipped out from the plant or manufacturing. So the key takeaway in this bit that he looked at was that if a factory produces products which are which were supposed to come out in a particular way, and that now are having a bit of a deviation in terms of the output which was expected from the output which was expected, then in other words, what he tried to do was to basically look at if the product or the process moves away from the desired specifications which have been defined, then there will be a cost associated with quality defects as the volume increases or as the number of products being shipped out into the market increases. And this cost can be calculated using the mathematical formula that he gave us, which is called the Taguchi loss function. Is that okay? So he gave us a mathematical formula, and that allows us to calculate, the loss which is going to be incurred by the company in meeting those number of products or units which are to be produced. For example, when a car model is being produced, and generally you would see, if you keep track of the cars in the market, car manufacturing companies, they change models every 4 or 5 years. So the life of a product for which the manufacturing facility, assembly lines are all changed, modified, are generally for a period of 5 years. And within a 5-year period, a car manufacturing company would fix a target for the number of models to be manufactured. Let's look at an example of Mercedes E-Class. Now, every 4 years, what you will see is a new variant of the model coming out. But at the end of the 4 years, they do what is called a, let's say that is called a cosmetic upgrade. They might change the lights, the exteriors, some cosmetic upgrades are done to refresh that model. And that 1 year is used for the newer model to start seeding into the market from the old model being shut off or stopped manufacturing. So if I look at 5-year cycle, now for production of the chassis, for production of engines, from production of upholstery, the parts, because all the models undergo change every year, they would conform to, say, a product line, or they will create basically a product line which will have processes, machinery, equipment, everything in such a way that at some stage, what you are going to see is that there would be X number of models they will think they will be producing during this, during the production line. So if I look at, let's say, this particular part, and I just hypothetically say that they would produce 5 million vehicles in this product variant for a period of 5 years. Now, after 5 years, when the product variant manufacturing is stopped, what the company would then look at is, this is what the product specification, obviously they're monitoring it. I'm not saying they'll do it at the end of 5 years, but whenever they do monitoring, they're going to see that there are some deviations or some variations which are happening, as far as the product being rolled out is concerned. Now, over a point in time, when all these models have gone into the market, they would then calculate if there are any defects or any issues which are coming through. And then because the product did not conform with the variations which did not conform with the actual product specification, and it led to the variation in the product during manufacturing, what would be the defects which will be produced, and these defects, how much will it cost for the company to rectify these defects? So sometimes when you see recall of cars happening, and say for example, in terms of how they are basically they need to, say for example, recall these cars over a period of time, then they will calculate, okay, we made that much profit, and this is the money which has been spent in order to rectify those defects. Or if there's a profit or still a loss, if there's a loss or still a profit which the company has made, and that would be done using the calculation of using this mathematical formula called Taguchi loss function. Is that okay? Is that clear? Just as an example, this can be applied to lots of different obviously examples within different manufacturing setups. And this approach essentially then allows companies to understand what would be the loss that they would rack up, essentially in terms of let's say creating a product which they thought that this will conform to the product specification, but over a point in time has resulted in a deviation, and that deviation at some stage will cost the company X amount of money to correct, and that could be calculated using the Taguchi loss function. Is that okay? Any questions on this?
No, sir.
So some of these, and then there's another method that we are going to look at. So the other method is called the Poka-yoke method. Now, this is also a technique which is generally used, by manufacturing companies to essentially look at, finding out deviations which could happen in product/process design. Now, Poka-yoke is a Japanese term that means mistake proofing. That means you're going to, make sure that there are no mistakes done, or error proofing, as we call it in English. Now, this concept is rooted in lean manufacturing methodology, and originally was developed by, the Japanese engineer Shingo. And he created this term, which is Poka-yoke, because he wanted to eliminate any errors that could happen in manufacturing, in service delivery businesses, or other processes in which you are looking at, the processes and product quality being prone to defects or errors happening. And if they are not corrected or not monitored due to human intervention, this could lead to production of goods which could essentially be, having defects, and those defects could then be costly to rectify for the company in the future. So the primary focus here is on process design in this particular method. And the process design looks at making or coming out with a process which is going to allow defect-free production of goods to happen. And if there are any errors or defects which are detected, then there would be immediate attention provided to it, so that this can be corrected at the early stages before the product is actually shipped out from the factory. Now, if I talk about the Poka-yoke technique, this can be done in or utilized in various forms, such as it could be used for, let's say service business. It could be used for manufacturing business. Now, these defects could be something which could be visually seen, because there are clues coming in. For example, if the painting is happening in a car manufacturing, plant, and the paint color variations are happening, although you've fed in beige in the in the coding, but the machinery is actually producing a variant of beige. And in those cases, this would be visually visible, because there are people who are trained to pick out these variations using visual clues. In some cases, you would look at, the paint variant being a bit thick. So sometimes you would see people who are inspectors or quality insurers wear gloves and they run their hands over the cars across the body of the cars to see if there are any variation. What is that variation? That will be a physical variation they'll be able to pick up, wherein the coating of the paint is applied, which is a bit thicker, but then in some places a bit thinner. And what they would do is reject that product and that will go out. So this technique could be used to detect defects at an early stage, and that can be done in various forms: physical form, visual clues, or even in some cases, that might require process design changes to be done to ensure that coding done into the machines or the assembly of the machines done in a way produces the desired output. And one of the key principles behind the poka-yoke technique is to make it easier for the operators to perform the task correctly. So when you look at a lot of people working within factories and they are required to work with specialist machines to produce goods, and one such example that you look at is shoe manufacturing or sports shoe manufacturing by Reebok and Nike and Adidas and a lot of other brands, you would generally see that there are various parts of the shoe which are being assembled using different machinery by different operators. Somebody is sewing in the sole, somebody is sewing in the top of the shoe, somebody is pasting the sole, and some of them are installing the inners of the shoe. Now all is being done by different machinery. So here the poka-yoke method looks at individual processes in the manufacturing of the product, finished product, and what they will try and look at is to make it easier for operators to perform their task correctly. And this is generally done by reducing the need for let's say vigilance and the machines, let's say the humans relying totally on the machine to be able to carry out that task. And thereby what it does is it reduces waste and produces products in high quality which meets customers' requirement. Now, if you look at understanding how the soles are cut, you would generally see giant streamers cutting out, rims of leather and sole, primarily, which are going to be used for manufacturing. So generally, you would see it involve laser cutting or very fine cutting, but the layout of the cutting is normally drawn out by the human, and that is where this method tends to be, making it easier for operators to follow the guideline in terms of how the cutting has to be done. And thereby it reduces, waste as far as output is concerned from the finished product. Is that okay? Is this technique clear? Now, when we look at these two techniques in particular, the Taguchi loss function and poka-yoke, they help in essentially contributing to detecting errors in product quality and process design. And they are efficient in picking out variations which can occur because of either human intervention or because of code not being properly set into the machinery, or in some cases, when we look at finished code products being sent out and then data being collected, that would then help them, crunch decision basis, the data crunching which has been done to minimize any sort of errors which can cause variations in process/product quality. Is that okay? Any questions on this?
No, sir.
Now, let's look at the last bit, which is Six Sigma approach to quality. Now, when we talk about the Six Sigma approach to quality improvement, this as an approach, has a bit of a timeline in terms of how this was started and, where it gained significance. As I mentioned yesterday, it was, it gained significance in the 1980s when the engineer Bill, in Motorola essentially came across with a concept that we need to look at meeting quality standards and looking at reducing defects per million to as low as 3.4. So if a product is manufactured and if it is virtually defect free, and that is that if you manufacture say 1 million cars and only 3.4 of those, or let's say certain number 3.4 of those cars develop defects, then you are going to be conforming to what is called Six Sigma quality standard or Six Sigma performance standard. And that would mean that your product is virtually defect free. And this process is now seen as a methodology which was initially developed within Motorola. And when we look at employing this or using this, it basically conforms to what is called define, measure, analyze, improve, and control, which is called DMAIC, DMAIC. So this methodology focuses on a process called DMAIC, which is how do you define the process, how do you measure the conformance with the process, how do you analyze any variations which can happen in the process, then look at finding out gap areas and then putting implementation for improving these gap areas, and then keep controlling them, keep monitoring them to ensure that the product is consistently being produced, which is meeting the DPMO standard, which is the defects in parts per million, and keeping it below 3.4, which means that you're conforming to Six Sigma, quality standard. Now, this approach and framework, which is referred to sometimes as DMAIC, is a systematic way which basically helps identify problems, collects data to analyze it, and then looks at finding out what is the root cause of this problem, and looks at making improvements, implementing it, and then maintaining those improvements which have been gained by making those process changes. And that helps in conforming the manufacturing side of things to what is called the Six Sigma standard of quality. And because it involves, these six processes, define, measure, analyze, improve, control, and then maintain it, the sixth part, that is why this is normally grounded or called as the statistical principles of Six Sigma, and they help in basically achieving what is called a standard of quality, which means that you are removing defects, you keep identifying the defects, you keep removing the defects, and then you keep minimizing variability in the business and business processes, thereby keeping the defects lower than 3.4 parts per million. And that means that your company, your manufacturing, your production facility is now conforming to what is called the Six Sigma standard of quality. Now, this process is basically, data driven again, because you have to look at producing in volumes, and then you have to look at conforming and testing the products to see if they're conforming to the Six Sigma standard of quality. And this requires, the DMAIC process to be used and utilized again and again. Now, within this process, because it has been around now for a few decades, there are different types of, let's say, role specifications which have been created in Six Sigma. So there is a green belt, there is a black belt, there's a master of black belt, and each of these are what are called, let's say, specialized training, programs that you get into. And when you achieve this, then you are considered to be having the ability to be able to manage these processes at various levels within the Six Sigma, quality improvement program. And the types of belts, when we say types of belts, when we say in, Sigma, which is the variation in green, belt, the black belt, and the master of black belt, what we are basically looking at conforming to is they have various standards. So it starts from white, then goes to yellow, then goes to green, then black, and then you are also championed and called as the Six Sigma champion. Now, these belt and rankings essentially, were basically created as a process to look at helping improve processes and reducing defects. So like we talk about quality circles and we look at people at different levels of experience, similarly, these belts basically provide various levels of expertise, and they represent the skills that you have been able to master in order to detect quality variations and defects within a particular process. So if you are having a yellow belt or white belt is somebody who's starting off on Six Sigma, yellow belt a bit more experience. People who have yellow belt will typically be members of teams who are involved in Six Sigma quality improvement program. They will assist people who have green belts and black belts in projects, but may not lead the projects. So in the case of green belt, what you are going to see is green belts, people when they achieve a green belt, they are then tasked with leading smaller teams or smaller Six Sigma projects within a work environment, and they will be doing it under the guidance of black belts, people who have achieved a higher position in terms of understanding of quality and quality standards with Six Sigma. The green people who have achieved the green belt will essentially have more in-depth understanding of Six Sigma tools and methods than people who are in in yellow or white belt. Black belts are generally going to be project leaders. That means they are going to be responsible for leading significant process improvements across the projects. They will have a comprehensive understanding of Six Sigma principles and tools. And that means the DMAC or the DMAV, DV frameworks. And these would be useful for them to introduce, process-related improvements. Now, somebody who's a master black belt, that means that person is an expert or a highly experienced person with number of years of experience and different number of projects that they have worked on successfully, and they would be tasked with providing mentorship or coaching to people who are in black belts or green belt category, so that they are tasked with playing maybe a strategic role in implementation of some of these Six Sigma programs and quality improvement programs across the organization. And then somebody who's a champion, if we are to go into detail, the champion would be somebody who's a very senior leader who would promote the concept of Six Sigma and the initiatives which Six Sigma, provides within the organization. And they are basically, what are called champions of projects when a company launches a new project or a new division, or if they have to look at, making sure that everybody understands the importance of Six Sigma within the organization, then these champions would be put into, would be tasked with that kind of work that they would need to do to inform, educate, and train all employees within the Six Sigma methodology. Now, this particular, methodology is based on reducing defects and improving quality in terms of the products being produced, which meet the desired customer requirements, and thereby creating specific customer satisfaction and user experience, as sometimes now we use the word or term in technology products. Now, this framework and tools which are using DMAC, essentially are a continuous quality improvement process, and that is where this practice of Six Sigma is not something that the company has achieved a Six Sigma recognition or has the Six Sigma quality seal. This process is basically a continuous process of quality improvement which the organization needs to be at and keep following in order to maintain the quality Six Sigma standard quality approval seal within the organization. Is that okay? Any questions on this?
Yes.
No question.
Okay. The last part sorry, go on, Ishika. Any questions, Ishika?
No,
Sorry.
nothing.
All right. Okay, that's great. So the last part that we're going to look at is quality improvement as a cross-organizational activity. Now, when we talk about quality improvement, if you're depending on the size and scale of organization, what you're generally going to see is that if you're a small company, if for example, you run a grocery business, or you run a post office business, or you run a small company as a call center or a software organization with 3, 4, 5, 10, 15 people within the organization, just giving an example, here your meanings of what quality and quality improvement means for you as an organization might be slightly different. If you look at small medium enterprises, 50 or more employees, that meaning would be slightly different. If you look at small medium enterprise, small medium businesses and small medium enterprise, businesses up to 50, enterprise up to 250 people, you will generally see that their meaning of quality and quality improvement processes would be slightly different. If you see a large PLC or a corporation with hundreds of employees, then there the improvements in terms of quality or how quality improvement programs are recognized, understood, and implemented might be slightly different. So when we look at the focus of quality and the creation of quality department, whether it be just a quality manager or a department which has quality assurers, quality officers, quality managers, or people in the operational roles working to ensure that there are things which the company conforms with and its activity conforms with legislation, compliance, processes, customer expectations, and obviously looking at the management vision for the organization. That is where you would see this to be a cross-organizational activity. Now, it could be seen in a small organization, it could be seen in a large PLC, but the basis of how the approaches would be, applied or grounded within various organizations, depending on the size and scale of the business or the organization, will be based on going back to the three views: systems theory view, resource-based view, and balanced scorecard view. So we discussed resource-based view earlier. Systems theory, or when we talk about systems theory in particular, this view, and if you look at balanced scorecard is something that we've studied in this unit in Learning Outcome 1, wherein the performance criteria, or measurement which has to be done by taking into account financial, customer, internal processes, and learning and growth for the individual takes into, these four parameters are taken into account when we look at balanced scorecard being used as an indicator to implement cross-organizational, activity to improve quality within the organization. When we talk about systems theory tends to be, so if I talk about systems theory in general, we don't need to do that. But when we talk about systems theory in the context of operations management, what we're going to see is that when we talk about systems management theory or systems theory, we are looking at an alternative approach in terms of how planning and management of organization functions can be done. And these planning and organization of, organization functions tend to be based on the business, the cost of business, the cost of machinery, and the cost of quality, and then the customer expectations, which the company is trying to meet by producing, a particular set of product or service. In this case, what we look at in general, when we talk about, systems theory, this theory as an approach, will allow, let's put it this way, various functions of the organization to be considered to develop a quality, management program within the organization. And this would then, play into helping the management make decisions or take actions which are going to, basically benefit the organization in terms of producing goods and services which are conforming the requirements of the customers. Resource-based view, if you recall, when we talked about the RBV view, our basic understanding on the resource-based view theory was that everything is finite. So when we talk about the resource-based view, what we are looking at is considering and taking into account that the firm's, sustained competitive advantage is based on valuable, inimitable, and non-substitutable products, which is looking at some of the capabilities and resources which the companies can use to basically create competitive advantage and then produce products which are going to be useful for the company to sell in the market to customers. So here we look at resources are valuable. We also look at that firms can focus on these resources, which could be VRIN related, which is rare, inimitable, non-substitutable, and valuable. So when we look at this as a concept, we are going to use resource-based view. And in this case, an example that I had given earlier was that a technology company may be able to gain, say, a competitive edge by processing patented technology, that its competitors cannot replicate. So if you are like Tesla and some of the technologies that it utilizes in its cars or Tesla motors is proprietary and it is protected by intellectual property rights, it is very difficult for competitors to replicate that particular technology for battery recharging. So Tesla cars, you can, recharge or they have batteries, technology in the batteries, which allow faster recharging. And this is proprietary to Tesla and which is very difficult to replicate. Although competition is catching up, but it is still very difficult to replicate. And this uniqueness and the inability of rivals to substitute or imitate the technology in the Tesla motor, products as a car, gives the firm Tesla Motors a sustained, competitive advantage. And this is based on resource-based view. So company has been able to create something which is given it a primary advantage in the market because of the technology being proprietary. So these quality improvement activities, which can be done using systems theory, resource-based view, and balanced scorecard, which take into account for, let's say, measuring the performance of individuals within the organization, but with 4 aspects, looking at both financial and non-financial metrics, and financial metrics, including, say, for example, profits the company is able to make on products. So financial, those will be financial, but you look at customer benefits, you look at internal processes, and then what is the learning and growth which is happening for the individual would be essentially streamlined using process design to finally bring quality improvements across the organization. So this would be for employees. This would be for companies looking at, manufacturing and, essentially looking at setting up facilities to be able to produce mass manufacture goods, and systems theory being, although this is a transdisciplinary field, and this looks at, examining the relationship or interdependencies between different side of things like machinery, raw material, suppliers, partners, employees, and then looks at a complex set of, parameters which allows the company to work and, look at the interconnectedness of different departments within the organization. So things like, is the marketing department essentially, advertising the product correctly, or the unique features of the product correctly? Is the manufacturing, department which is producing the product providing accurate descriptions to the sales marketing department, which then is used to produce specifications, flyers, brochures, material related to promotions, and is it accurately depicting that? And that would be, done using what is called the systems theory. So it is essential for addressing complex issues which are taking into account, complex relationships and interactions which will happen between various departments within the organization. And these areas, when let me put it this way, when quality tends to be a process that could become a cross-organizational activity, it can pose advantages and it can create also challenges for the organization. Advantages that the organization gain could be in terms of holistic improvement of, products, or, things like, for example, the company achieving an objective, making something which is relevant, profitability is good, employees are happy, the activity of the company is customer centric. That means Apple as a company, if you look at, they produce lots of products, but most of the products, they say we put the customer at the center of its universe, where all the products being produced are, essentially being produced for customers. It is very important for them to ensure that the customer experience, and usage of these products helps them solve problems and address problems. And that is where their activities are customer centric. Innovation, resource utilization, all these tend to be advantages if quality is applied across the organization as an activity to improve process and product quality. And some of the challenges that it could pose could be, say, things like, complex coordination. Within large companies or within smaller companies, you would find this as a problem wherein things are not very well defined, they're not clearly documented. And in those cases, coordinating, things between different people, organization, or departments tends to become, a complex process. Sometimes you could look at, there could be change or resistance to accepting some of these quality processes and, process control charts or designs, is because the company itself or the employees themselves feel that they have very relevant, they do not have autonomy in terms of working within various functions. So sometimes you would see when change is being introduced, and we look at the Deming's 14 change principles, that he has specified, sometimes you would see that people are not willing to accept change. They say, why should I change, or why this process needs to change, or why does this have to change when it is working perfectly well? So they fail to see the larger picture of why change is being implemented within their department or within their daily roles and responsibility, because the organization might be moving to a different direction of, meeting customer demands. So when you look at the early 2000s PC industry in general, as a good example, was desktop computers, were the main primary source of accessing the internet and was the main primary source of getting onto the internet. Then laptops started to become more affordable. They became the standards. But when we see the advent of the iPhone, the iPad in 2007 and 2009 respectively, and tablets then becoming mainstream, PC started to lose, or PC companies started to lose their market share because of the change which the customer demands and expectations were experiencing, which means PC was no longer a device, the only device to access the internet. Then started smartphones and tablets started to chip into and started eating away some of the market share or the majority of the usage which PCs were doing. And this change within organizations, when companies wanted to change, like Dell Computers wanted to change, they wanted to move away from that. Microsoft has moved, some of the other organizations have moved, and there has been a change to resistance to change within the organizations as well by employees, and that tends to be a major challenge. So when Steve Ballmer left Microsoft and Satya Nadella took up Microsoft, he took the company into a different direction. Up until Steve Ballmer, Windows and Windows platform and Windows revenues were the highest, contributor to Microsoft's bottom line. But when he stepped in, he saw the shift happening and everything moving to cloud and cloud-based computing. He started to put focus on cloud computing technologies or cloud management side of things, which has helped Microsoft diversify from the revenues that were predominantly Microsoft as an organization was dependent. And in order to bring that across, he has faced a lot of change resistance within the organization, and that has been overcome by training, development, and also slowly and gradually creating opinion and thought leaders within Microsoft who have managed this change from an employee perspective. And then you look at resource allocation. Sometimes if organizations decide to change their course of action or their go-to-market, you would generally see that the organization would need to realign itself in terms of its manufacturing facilities, the way it targets its consumers, and also looks at procuring resources or getting procurement for resources from its suppliers, and they have to reinvent or redesign their supply chain and storage and warehousing facilities. And in this, generally what you're looking at is they are looking at even people, hiring new people, which is bringing fresh, talent into the organization might be required. And this would also be a challenge from a point of view of resource allocation. So when quality improvement techniques are applied across the organization, they could pose benefits, they could pose advantages, they could pose disadvantages or challenges, and they also have to be understood from a context and a viewpoint of, I would say, this particular learning outcome that we are looking at. And that helps us conclude, learning outcome 3. So what we've understood from studying learning outcome 3 is we've looked at 2 main aspects of the unit. One is, what is the role of total quality management in operations management? What is the role of TQM in operations management? And in that we have studied, continuous improvement, which is primarily Kaizen approach. We've understood what is the difference between quality assurance and quality, control. We've looked at the work of, Deming and Duran, which is quite important in the creation of the, plan, do, check, act, PDCA cycle, and also the planning which is required for looking at quality control and process control. Then we looked at some of the approaches of TQM, which are documented as just-in-time, lean thinking or management, quality circles, statistical process control, and process architecture. And then we went into the role of technology and software, very briefly looking at how it supports the activities in the quality management area or quality improvement area within an organization. The second part that we've studied is basically focused on understanding process and quality improvement, product quality improvement, which are required to be done within the organization. What are the differences between the two? And then how are these differences different when we apply them to the quality, continuous quality improvement, CQI part of the program within the organization. Then we looked at how do we diagnose changes or problems, or let's say changes in, not say changes, how do we diagnose variations which can occur because of the changes that can happen within product control and quality control side of things. So product and process control side of things. And then we looked at what could be the reasons of these variations. We looked at what are the tools and techniques used to detect these variations, which is the Taguchi loss function and the Pokayuk technique. And then we also covered briefly the Six Sigma approach, of quality, continuous quality improvement, process. And then lastly, why is quality very important as a cross-organizational activity, and what challenges and advantages or what benefits and challenges does it pose for the organization? So this wraps up learning outcome 3 for us. Is that okay? Any questions on this so far? Any questions?
No.
Okay, now what do you have to do between this week and next week when we do learning outcome 4 and the assignment discussion session part 2 on this unit would be to primarily look at understanding and going through some of the case studies which I provided and master some of these concepts that we've discussed for learning outcome 3. Because in learning outcome 4, we are going to be looking at conducting a strategic risk analysis or SRA, and this will be done for an operation from an operations point of view within an organization. So we'll be looking at putting into action some of these concepts and theoretical frameworks that we have learned in the learning outcomes 1, 2, and 3. And that would be a practical side of, looking at using it from a management point of view. Now that you've understood what is operations management, what we need to be able to do is wear the operations manager's hat and then look at an organization, look at risk analysis, look at risk management, look at what risks are posed if quality goes astray or quality is not managed within the organization. What could be the potential threats which the organization can face if quality of the product deteriorates, and what could be the expectation from customers as well as stakeholders' point of view in the company looking at dealing with some of these risks and challenges. So that will be a management perspective that we have to look at of putting what we have learned in learning outcome 1, 2, 3 into use for learning outcome 4. So we'll meet up next week, same time, 9 o'clock. Until then, thank you so much. And if you have any questions or any things or issues that you face, please feel free to write to me on, on email, and I will try and provide additional information so that you are able to, get the relevant knowledge on what we've studied in learning outcome 3.
Okay.
Thank you very much. Thanks for joining, and bye for now.